Mabuhay everyone, I am James Brian Corpus and we are Group 1 from 11 Mendeleev. And today, we'll be discussing the sine function and how variations in its parameters shape the graph. Let's dive into the standard equation and let's examine the impact of altering the letters A, B, C, and D. The standard sine equation is y is equal to A sine of bx minus c plus d, which includes A, the amplitude, B, the frequency or period, C, the horizontal shift, and D, the vertical shift. To better understand what I mentioned, my groupmates will give some examples so you understand the parts of a sine graph.
Now, what if the A changed? A represents the amplitude of the graph. The amplitude determines the vertical shrinking or stretching of the graph. Let's use this example, which is y equals 5 sine x. In this example, A is 5, resulting in a sine curve with the amplitude of 5 reaching 5 units above and below the x-axis. If we adjust this slider in Desmus, we can change the amplitude because A corresponds with the amplitude of the wave. If we set it to let's say 10.2, the amplitude will be 10.2, meaning it reaches 10.2 units above and below.
What about when the value of b has changed? What does b determine in our graph? Well, it determines the period. The formula of the period is 2 pi over absolute value of b. The period is the amount of cycles the graph repeats within an interval. For example, y is equal to sine of 5x, with b as 5. The curve completes 5 cycles within the interval of 2 pi, creating a higher frequency. If the value of b is greater than 1, the cycles of the graph will shrink. If the value of b is less than 1 but greater than 0, the cycle of the graph will stretch.
What if C change? The C in the sine equation y is equals to A sine open parenthesis bx minus c close parenthesis plus d controls the horizontal shift or phase shift of the sine curve along the x-axis. For example, y is equal to sin open parenthesis x minus 5 close parenthesis. Changing c to 5 implies a phase shift of 5 units to the right along the x-axis. This means the sine curve will start its usual cycle at x is equals to 5 instead of x is equal to 0.
What if t changed in f of x equal to sine of x plus 5? The change in c is similar to the change in d, but the difference is that d controls the vertical shift of the sine curve, where the sine function graph as is its origin, and the change graph when added units in d will raise the whole graph by said amount of units. Same for subtraction. Goes below origin sine function. For example, let's have y equals sine of x plus 5. With d as 5, it will lift the entire curve vertically by 5 units. Another example is y equal to sine of x minus 7. With d as negative 7, it will move down the entire curve vertically by 7 units.
Now, if we change everything, for example, y is equal to 2 sine of 3x minus 4 plus 5, we will see transformations affecting the amplitude, frequency, horizontal shift, and vertical shift all at once. A is 2 indicating an amplitude of 2. This means the curve will oscillate 2 units above and below the x-axis. B is 3 showing that the curve completes 3 cycles within an interval of 3 pi along the x-axis. C is negative 4 suggesting a horizontal shift of 4 units to the right along the x-axis, and d is 5, resulting in a vertical shift of the entire curve 5 units upward along the y-axis. Thank you for joining us on this discussion about the properties of a sine function, and we hope that you learned something about our exploration of the amplitude, frequency, horizontal shift, and vertical shift. Again, we are Group 1 from 11 Mendeleev. Thank you.